Alright, so Assalamualaikum warahmatullahi wabarakatuh and a very good evening. My name is ZAFRI AZIZI NORZAIREE. I'm from University Malaysia Perlis at UNIMAP, and then I'm a major in material engineering. So for IIDEX 2025, I would like to present our product, which is called GReeN Slag Concrete. Right. Why we came up with the idea for this project? So basically, this project is focused on sustainable development in construction industry by utilizing industrial waste, specifically in blast furnace slag. So blast furnace slag (BFS) is going to be an alternative for the OPC, ordinary Portland cement. OPC is the main composition used to produce concrete. So we are going to replace with more green material, which is from waste. We're going to turn as a main composition for the concrete production. So this idea actually is going to help us on reducing the carbon dioxide emission during the concrete production, and also is going to conserve and save more energy during the production for concrete. And then in overall, we are going to promote environmental practice for industrial application. Right, before we continue with the methodology of concrete production, I would like to highlight the novelties of our project first, which is alternative, low cost in making, and then we use industrial waste, which is BFS, and then we eventually turn waste into wealth. Alright, so for the methodology, I would like to make a comparison between ordinary Portland cement and a GReeN Slag Concrete. So I would like to highlight the ordinary Portland cement first. So we're going to go through one by one. As you can see, to produce a concrete, we have to gather all the virgin material first, which is limestone, clay, iron ore, aluminum ore, magnesium ore, and etc. To get all this, we can do three most efficient and common method, which is quarrying, hill cutting, and mining. So by doing these three, it's going to cost us environmental issue. Not just that, the initial investment is quite significant. We have to consider labor cost, logistic cost, supply power cost, and then machinery operating costs. So the cost here is quite big. And then after we gather all the virgin material, then we're going to transfer to a factory that operate grinding and mixing. So all the virgin material is going to be grinded and mixed together, and then we're going to sinter up to 1450 Celsius. So this is where extraction process happen. Waste is going to be removed, and the valuable material to use for the production is going to be collected. And then we're going to mix with clinker and gypsum. This is two common material that work as catalyst and to enhance the mechanical properties of the concrete. And then we mix, that's how we produce the OPC concrete. Alright, now I would like to discuss about GReeN Slag Concrete methodology. As you can see, our product process is less complicated compared to ordinary Portland cement. So the yellow box is the step where we skip in our product. So basically, we reduce energy consumption, we reduce virgin material use, we reduce carbon dioxide emission, and we reduce overall costing. So first, we have to collect all the iron blast furnace slag, where you can get from any factory that operate blast furnace. So after the factory collect all the valuable material, the so-called waste is like they're going to store it somewhere. That's where we can collect it for free. And then we're going to grind it and mix it with alkaline activator, which is sodium silicate, and that's how we produce our product. Alright, now we are going to discuss about the graph. So the data we collected is actually tested by the MTDC, one of our collaborators. So it shows that our product have been through compressive tests to determine the strength over curing time, which is under the code of Malaysian standard EN 12390-2 and -3. So that's an applicable standard for the concrete testing. So we conducted this test with 4 variety, which is, as you can see on the table, the blue one is OPC, the red one is 60% of slag, and the green one is 70% of slag, and the 80% of slag is on the purple color. So in overall, as you can see, the red one performed the best. Alright, so now we are going to discuss about the product composition. As you can see in the table, at the first column, which is we have Portland cement, Eco Slag cement, and GReeN Slag Concrete. So it shows that our product have almost the same numbers as the Portland cement, which is, that's why we choose blast furnace slag as our main composition for the concrete production. Alright, so now we have seen the environmental benefit, but you might ask, can this really work in the market? So let me show you the commercial potential for our product. So first, it's required low energy during production. And second, it can reduce up to 90% of the carbon emission compared to the OPC in the market. So next, it also can achieve very high strength at early curing age, as you can see based on the graph. So at the same time, it's also very durable against the aggressive environment such as toxic rain that may contain aggressive chemicals. So with this advantage, I think the GReeN Slag Concrete has strong value not to only scientifically but also commercially. Alright, so after looking at the commercial potential, let's move to the industrial application of our product, which is we all aware that our product is mainly focused on development sustainable in construction industry. So in building construction, our product can be used to cast foundations, columns, slab and shear walls for the main structure. And then for the infrastructure, our product is suitable for building bridges, flyovers, tunnels and a drainage system. It also can be applied in a water-related structure such as tank, curbs and a retaining wall. And because of its advantages, it performs very well in a harsh environment, especially in a coastal and industrial area. So this shows that this GReeN Slag Concrete is not only an academic idea, but it's also a strong potential for real industry. We have come to an end, so I would like to conclude everything as our conclusion, which is GReeN Slag Concrete is not only sustainable and commercially valuable, but it also ready for real application. So this product is also patented, Malaysia patented, and we are working with industrial collaborators, which is Anju Industri Berhad located at Penang. So they will supply us as much as slag that we require. And then we have MTDC as our testing agency. And with this step, we believe that GReeN Slag Concrete can move from research to industry, supporting sustainable construction and contribute to the SDG. That's all from me. Thank you so much. Have a nice day.